The next topic that you have is integration. So here in this case of integration, now it's just the opposite, or you can say the reciprocal or the inverse of differentiation. So whatever formulas that you have studied under differentiation, using those formulas, we are trying to get the formulas under integration. So we'll just quickly glance over all the list of formulas that you have. So the formulas of the differentiation. And the formulas of integration. If you are perfect with the formulas of differentiation, then formulas on integration will be very easy for you. How exactly do we represent the integration? Suppose if you are taking a function y is equals to f of x, and if you want to integrate this function, we represent this function by, usually we represent the integral as I is equals to, therefore it will be integral of. So I need to integrate this given function, right? Integral of this symbol that we are using, f of x into dx. So in general, we represent the integration as integral of f of x into dx. If that is the case, now let us try to see how to get the formulas of integration using differentiation. So the basic result, I hope you already know it. I'm just giving those list of formulas again. D by dx of x power of n will be n x power of. But if you go to the integration, is, if I'm trying to write down, it is integration of x power of n into dx, then its formula will be x power of n plus 1 by n plus 1. Plus whenever you are trying to integrate, so therefore we'll be adding the constant of integration as plus c, right, in all the cases. So similarly, we can write down all the list of, what are the list of formulas that you studied. We'll take down all those one. So using the same one, it is d by dx of, suppose in just if I remove that power n, so I'll be getting d by dx of x. Differentiation of x will be what? Be 1. Suppose here, if I just eliminate this x power of n and just write down dx value, then integration of dx will be, right, it's just x, right, x, or integration of 1 I can say. So if you want, you can write it, usually we write it as dx, but if it is confusing for you, you can write 1 into dx. So integration of 1 into dx will be x, the constant of integration. All right. If you go for the exponential function d by dx of e power of x or e power of ax. So we know differentiation of e power of ax will be. Similarly, if I go for integration, it will be integration of e power of ax into dx. So its value will be e power of ax divided by, it comes the denominator, divided by a plus the constant of integration c. So similarly, suppose if I take the trigonometric functions like d by dx of, it is sine of ax or sine x itself, sine x, cos of x. But if you go for the, this is differentiation. Now if I go for the integration value, integration of say sine of x into dx, will be minus cos of x plus the constant of integration c. Then suppose if I am taking d by dx of say cos of x, so its value will be how much? It is minus sine of. So suppose if I am taking the integration of cos of x into dx, its value will be how much? Value will be sine x plus, its value is given over here, and this value is given over here, right? You can go ahead with other trigonometric functions like d by dx of, suppose if I try to differentiate this tan value, it is tan of x will be what? Secant square of x. So in the same way, if you go ahead with integration of secant square of x, just the opposite, right? What will be the integration of secant square of x? Tan x, right? Secant square of x will be equals to integration you'll be getting. Similarly, if you go ahead with the other values over here, that is d by dx of. So what we have after tan, you're taking cosecant. So you can take the value to be cosecant of x. So cosecant of x will be what? Minus cosecant, right? Minus cosecant into cot. So in the same way, I'll just try to list out the other formulas and then I'll be giving you the integration formulas over here. The next value that you have is d by dx of. With respect to cos, you can write secant. So secant of x, its formula will be what? It is secant of x into tan of x, right? The next value that you have is d by dx of. So after secant, what you have? Cot. So cot of x, its value will be equals to how much? So, but for this three, there will be some variation when you're writing it in the form of the integrals. So if you're writing in the form of the integrals for say, if you want to write for cosecant and cot, what you're going to write? Will be integral of the same thing. Negative sign you can put on the other side, right? So you can just take the value to be cosecant into cot. Cosecant of x into cot of x into dx. So what will be its value here? Negative, this I am taking integral. So negative value has to come here. It becomes cosecant of x plus what? Plus the constant of integration. Similarly over here, if you're writing integral, you'll just be writing this value. That is secant of x into tan of x. Its integral will be what? Its integral will be secant. So I can write that as secant of x into tan of x into dx. Its value will be what? For this, that is secant of x plus what? Plus the constant of integration c. Similarly for this also, you can write down the value to be equals to. Now, negative value, you can replace it on the other side. You can just take the positive value over here. Therefore, you'll be getting cosecant square of x into dx. Its value will be equals to minus, you can send on the other side, becomes minus of cot of x. It is minus cot of x plus the constant of integration c, right? So similarly, you can go for the inverse. These are all trigonometric functions. If I go for the inverse trigonometric functions, so d by dx of, you have sine inverse. So sine inverse of x. So what is the differentiation of sine inverse of x value? So 1 by root of, it is 1 by root of 1 minus of x square. Now if you go ahead with this integration value, integral of, if I take this one, 1 by root of 1 minus of x square into dx, then its value will be what? Its value will be sine inverse of x. Its value will be sine inverse of x plus the constant of integration c. Similarly, you can write down it is d by dx of, so because we are having the next value will be cos inverse. So cos inverse of x will be what? It will be minus 1 by root of x square. So similarly, you can go ahead over this one. Negative sign, you can write it on this side. So you just take 1 by with a negative value if you're trying to take this one. So I'll be taking 1 by root of 1 minus of x square into dx. So negative value if I'm taking on the other side becomes minus. But if you try to observe these two results over here, both the values are in the form of 1 by root of 1 minus of x square. This is also in the form of 1 by, and one more inverse trigonometric function that you have is tan inverse. So we'll just try to use the standard inverse trigonometric function. So therefore d by dx of what we have tan inverse of x. So its value will be 1 by 1 plus x square. So therefore what will be its integral of, if I'm taking this value 1 by 1 plus x square, so its value will be what? Its value will be, so if I'm taking the logarithmic function here, d by dx of, what is that? Log x. D by dx of log x differentiation is what? The same thing, if I go in the reverse order, 1 by x dx, what will be its value? Log of mod x, log of x plus, the values will be c, right? So there are many formulas. We just listed out the basic formulas over here, right?